Okay, so we have the Calderon mechanism. Now we will take up the another one, which has been given by Roland Petit. So this reference you can go back and check. So here also, this is the second mechanism which came out to be wrong hypothesis. So we have A and D, C and D, and here it goes through a tetramethylene intermediate where C, H and CH over here, and they make a bond with a metal. And this is a kind of tetramethylene intermediate. Once the metal is lost, so again a pairwise mechanism, A and C would make a bond and B and D will make a bond. So here we can say that, so one is Calderon, which gives a cyclobutane intermediate hypothesis. The second one was by Petit, gave tetramethylene intermediate hypothesis. So these both of these went wrong. Now we can take up the another one. So before talking about the Chauvin mechanism, we have one more in hand, which has been given by Grubbs. Which involves a metrocyclic pentane kind of intermediate. So if we have CH double bond CHR and double bond CH2 and two molecules of it, so they will first be in interactions, the pi interactions with the metal, and then later on they would form CH, CHR, R, CH2, metal, CH2, which undergoes rearrangement and then would form CH2. So this molecule and this molecule can come together, CH2, CH2, CHR, CHR, and metal. And ultimately, this would come as CH2 double bond CH2, having a pi interaction with metals, CHR and CHR. So metal can release out and you can get a different molecules over there. So what started with, these were the reactants, and this two are the products, so that we are getting from your cyclopentane kind of intermediate over here, which is involved in metal also. So this is the Grubbs mechanism, which we have taken into picture. Now the last mechanism that we have to consider is the Chauvin mechanism, which is the right hypothesis and been proven by many evidences. So it is a non-pairwise mechanism where many combinations could be possible. Here, if we are taking A, B, C, and D, and in presence of a metal carbon, so this involves a metal carbene involvement. And here, if A and C and B and D would make one pair, there could also be a cross couple between A and D and B and C. So this is a kind of chain reaction which continues and different products could be possible. So ultimately, what we have seen is, so normally in pairwise mechanism, we will be having only two products. Say we are starting with A and B, and then C and D. So this is going to give you A, C, B, and D. So this is only kind of pair we can expect to form these two. Whereas if we are going with the non-pairwise mechanism, so it would be giving us A, B, C, and D. It would be forming first product as A and C, B and D, AT, BC. So four possible products are there in this particular non-pairwise mechanism. So which we can explain very easily. But before that, how this non-pairwise mechanism by Chauvin was proven to be right, because the evidence came from the different reactions which was being manifested and being proven. So this is initiating metal carbon hypothesis, which we'll explain in next slide. So here, so the mechanistic consideration was being done by Grubbs in 1975. So what they took a kind of for the cyclization of the reaction, we could see and could propose like what kind of number of, so the validation could be given by like this experiment. So where we have a deuterated kind of alkene systems, olefins, and here it's protiated. So anyway, that is going to make, because when they are going to make a double bond, they will definitely make a single bond over here with another step of double bonded. So this cyclic group would be there. So one product is CD2, which we can expect to have from here and there. They would be making one pair because there are also two different kinds of alkenes. And since here it is having H and H only. Similarly, here the CH2 would make it. And there is also one possibility of CD2 and CH2 to make two, because two possibilities would be. This would combine this one and this would combine this one. This would come as one, this would come as two, and this would come as one. So that is a non-pairwise mechanism. But with the pairwise mechanism, it was found to be 1 to 1.6 or 0 to 1.6. So the validation of 1:2:1 ratio of these particular products. So the validation of one or observation of 1:2:1 products that actually validates the Chauvin kind of mechanism, which was evidently seen in the Jack's paper given by published by Grubbs. So now we can explain the Chauvin mechanism involving the metal carbene in full detail. So what we have in hand. So say for example, we are starting with this initial carbene and initial metal carbene. We are starting with that one. Okay. So what we are starting, the mechanism for Chauvin hypothesis of non-pairwise metathesis. So we are starting with initial carbon as X, where X could be anything. So this is your metal carbon, initial one. And it is starting with two substrates, which is AB and CND. So we will see, and the possible products if we are getting is A, C, B, D, A, D, B, C. So these are the products that explanation is required. So now we will see. So firstly, we are starting with X, M plus first substrate A and B. And here, as we know, in the Chauvin mechanism, it will go through a cyclobutane kind of structure. A, sorry for this. What we were explaining that if I'm starting with this X, this is my metal carbon, and this is my initial substrate A and B. So this will firstly go to a cyclobutane kind of intermediate formation where this A and B would be there, and then these two will combine together, X and A and M and B. So this is a new metal carbon. Similarly, if this is a scenario, this could be all X, M, here it is A, and here it is B, which will form B, X, and M, A. This is another second new metal carbene. Now, taking the first or any metal new carbene with C and D. So this will again go in this particular fashion where A is here, M, C, D, and this will form A, C, and another carbene. This is third new metal carbene. Or it could also form M, here it is D, here it is C, and here A, D plus M, C. This is fourth metal carbene, which is newly being formed. Now we started with this one. Now we can take up this one, this carbene also. let's see so what we ended up having, we took first case, now we are taking M plus CD can form B M C N D, or it can form M D C. So this would give you B or B with D. Now again with the new metal carbons, M D plus A D would give you DA and MD, which is the repetition, or BD with MA, that is also a repetition. Similarly, with C, we will be having M, A, B, C. This will give you CA, that is repetition, or C, B, A. So these many products could be possible only when we are having a non-pairwise mechanism. So this is what we have understood today, and we will summarize our week 2 session like this way. Summary of your week 2. So what we read about metallative repair chemistry, and what we saw in 2001, it was having good selectivity of the products, where earlier there were around 38 possible products. Then we talked about the metathesis reactions. So in metathesis reactions, we saw different kind of hypothesis. Fladdern hypothesis, then there was Pettit's hypothesis, Grubbs hypothesis, and Chauvin hypothesis. So this called as a cyclobutane intermediate responsible for the metathesis. Pettit talked about tetramethylene intermediate. Grubbs talked about metallocyclopentane kind of intermediate, and Chauvin introduced the metal carbon as the intermediate over there, which was responsible for carrying out the reaction. So these are the 4 hypotheses that we have seen today and discussed in detail. Where we got to know that the Chauvin mechanism is the one which is being acceptable, and it is the right hypothesis compared to this was wrong, this was wrong, and this was wrong. But it is very much important to know what they have postulated, so that we can get to know about where was the loophole in their hypothesis and why the Chauvin mechanism was being explained. So Chauvin mechanism was based on non-pairwise hypothesis. Sorry. So ultimately, the last thing of this particular live session was alkene and alkyne metathesis. So we have talked about the alkene metathesis in details, but there is also alkyne metathesis possible where we have not gone into like not much area. That area has not been explored much, but corresponding to the alkene alkyne metathesis can be explained very well. So here we have simple propylene where in presence of the catalyst. So as I said, metathesis is nothing but your cutting and stitching mechanism, where if we are taking CH3, CH double bond CH2, another molecule, this cannot be possible if there is no two molecules, CH double bond CH2. So these two will combine together and these two will, it's called cutting and stitching to the other part. So that's why we got CH2 double bond CH2 over here and this kind of another. So this mechanism, metathesis is basically a process where we can reduce or synthesize lower or higher olefins. So this is basically very much important in both homogeneous and heterogeneous catalysis. So this is what we have summarized in our today's lecture. Just taking a recap of it. So what we have talked about. So we have seen the synthesis, like what we have explained. We talked about the simply conventional chemistry. Then we talked about the metallative chemistry. Then how the selectivity is being better when it was witnessed in 2001. Then we saw different kind of metathesis reaction, like understanding the process, cutting and stitching process, where it was following the pairwise mechanism. Then how the labeling studies could help us to identify the products. Then metathesis reaction could be possibly coming from different hypotheses. So Calderon gave us a hypothesis of cyclobutane intermediate formation, followed by Petit talked about the tetramethylene intermediate, uh, which has been explained here. Then Grubbs talked about cyclopentane kind of moiety. And lately we got the Chauvis mechanism, which talked about the metal carbene intermediate involvement, where we can see, and it was being given in evidence fully. So now we can take up the assignment questions and see in details like what is there in the question. So here, this example I've already explained in okay. So here, this example has already been explained in the slides, where we have seen that so I can explain it one more time. So we have, so this is when it is involving acetylene. So this is not a conventional one. This is a metallative repe synthesis where from the acetylene we are making different products. So firstly, if here we can take up like this way. So if we are having so here if we are having Okay, so here I have already explained this question where we are taking this kind of moiety, and instead of this triple bond acetylene, we are having a another group over there which can be easily replaced when we are having a proton system. So how these 1, 2, 3, and 4, it also involves a titanium, but to just make you understand, firstly it will form a cyclic five-membered ring with the titanium, and once titanium is being introduced, then this particular third moiety will come into picture and would ended up having your benzene kind of moiety. And this was the answer for your particular question number one, where we are saying that the bond between this one and this one, because these would two would be combined with the titanium, firstly making a five-membered ring. Then when the third moiety of acetylene comes into picture, it would go to a benzene point moiety. Now, once this firstly this SO2 tall will go away, and once this titanium is being introduced and we have a proton, this can easily take your possibilities. I can show you the slide also. Okay, over here. So firstly, say it is similar kind of example where you have one acetylene, second acetylene, and titanium based thing. Firstly, it would cyclize into a five-membered ring. The third moiety, when it would be introduced, the SO2 tall would be removed because it would be connecting with your titanium. So it would form a TiX3. Once TiX3 is being formed, which is having isopropyl group, also isoperoxide group, and also SO2 all, where this can be easily removed when you are giving a hydrogen H positive source or iodine source or EHCHO source, which we have seen in the following slide, where this kind of product, when it is giving H positive, it would make an H over there. Similarly, here we have got ultimately this SO2 tall and this titanium product could easily be replaced by H. And if you'll see properly, this is the only possible answer which we can get over here if you try to form it by yourself. Now, the second question says, in conventional replicate synthesis, the cyclotrimerization of three different unsymmetrical acetylene would give you what? So, in conventional method, when we were talking about, so there we could only be getting a 38 different possible homo and cross cyclotrimerized compounds. But now in 2001, when the metal synthesis metal involvement has been taken into picture, then it would give you a proper selectivity of it. So the answer is option D, where in conventional way of doing it, it would give you a lot, many more different kind of products. Now the major product or products obtained from the metathesis of 2-butene and 2-butene D8. So this also we have explained. So this is your butene. Sorry. So your butene CH and CH, and similarly having a butylated version of your butene molecule. Now, as a metathesis part, these two will combine, as I said, the cutting and stitching process, and even if we go by the non-pair mechanism, these will combine in this one. And only the product which we will be getting is CH3CH, which is combining with the half part of CD3. So this is the only one possible product that we can get. Now the following reaction gives the basis for understanding of what. So since we are using an olefin with a labeled carbon in presence of the alumina catalyst, so it is giving you, it is also a type of metathesis reaction only, which we have explained in details in the video, in the presentation, where CH2 would combine together to give you one aniline, and one longer chain aniline olefin will be obtained. And this is to understand the concepts of the mechanism of your olefin metathesis, because when we have number of carbon increased and the label over there, we can easily identify it with IR doing mass and so on and so forth. So this is for the understanding of the olefin metathesis. So the metallocyclobutane intermediate in alkene metathesis was hypothesized by, as I've already made this clear, that we should be knowing like which scientist has given which kind of hypothesis. So as I said, R. Petit has talked about the tetramethylene kind of intermediate, Grubbs has talked about cyclopentane kind of intermediate, metallocyclopentane kind of intermediate. Chauvin has talked about your cyclobutane, which involves a metal carbene involvement. And Caldron has also talked about a cyclobutane, but it is devoid of metal. So this is metallo. Wherever we talked about metallo, that means that ring is involving a metal. But in case of Caldron, it is having a ring which is formamide itself, and it is having a pi interaction with the metal over there. So whenever it is a metallocyclobutane, it's a Chauvin mechanism. Then the sixth question says that for olefin metathesis, the following mechanism. So as I said, that this kind of intermediate, which is nothing but your tetramethylene intermediate. So this is being given by R-petted. So when we have two different olefins in presence of metal, it would form a tetramethylene intermediate, and then they would rearrange, and with the loss of metal, you will get AC and BT as your enemy olefin. So for a non-pairwise mechanism, the expected ratio of this one. So as we have already explained, when we have these kind of moieties, so when I'm taking CH2, CH2, similarly, downside would be having CD2, CD2. So here we know that it is going to make a double bond over here because this is itself going to form a product, but there could be possibility of these two combining with each other and giving out the result. So if they both combine together, that would be one. These two would combine together, that would be one. But if they both combine together to give an olefin, that would give you a CD2, CH2 two times. So this would be one, this would be two, and this would be one. So 2:1 ratio. It comes from a non-pairwise mechanism. The eighth question that has been asked is the involvement of metal carbene intermediate in metathesis reaction was first explained by. So this has been explained by T.J. Katz. So the mechanism, the intermediate thing has been involved by Chauvin in its hypothesis, but it has been explained by T.J. Katz. Now, the ninth question is the catalyst used in the following reaction. Again, this was the answer that has been given in the above question also. So the catalyst was the alumina and rhenium oxide. So this is nothing but to understand or to validate the Reppe mechanism. And the last question is, we have a given reaction again. It is a metallative Reppe synthesis, which we have explained already, where if it is having 1, 2, 3, 4, 5, and 6. So firstly, it would form a so this is 1, this would form 2, here would be titanium, then this is 3, this would be 4. Now this is having isopropoxide group kind of thing. Now when it is being treated with this group and C6H30, now it will again cyclize, and this would come into picture where it would connect with this one and this one. So therefore, it would form your group as, so here this was, now I can name it as 5 and 6. So this is 1, 2, this would form 5, double bond 6, this is 3, double bond 4, and this was having this group, and 5 is having CO2 tertiary butane, C6H30. Similarly, this kind of, you can rearrange it. This would come at that side and this would come at this side. So this is nothing but a metallative Reppe synthesis. So with that, we have covered the assignment solutions as well as the basics of our week 2 lecture. So I hope you guys have understood the concept. So if you have any further doubt, please let me know. I would be happy to explain.